All right, today we're going to be working on properties of numbers. Properties of numbers. Basically, the objective for today is to be able to simplify expressions by not using the order of operations. So here are the properties of real numbers that I'd like you to write down in your notes somewhere if you don't already have them. I will be going through each of these individually, so I will be moving along. So at this point, if you need to pause the video to write these down, I would do that right now. The first property is the commutative property. As you can see, there are two separate forms of this. There's the additive and the multiplicative. So the left one is always going to be the additive, and the right one's going to be the multiplicative for the future of this lesson. So for the commutative property, all it is saying is that if you take some number, and that's what these variables are going to represent. The variables are going to represent just some number, any number. So if you take some number A and you add that to some number B, you will always get the same number even if you do it the other way around. For example, if I take the number 2 plus 1, that will give me 3. If I take the number 1 plus 2, that will also give me 3. So all the commutative property is saying that if you take 2 plus 1, that is the same as saying 1 plus 2. This is a true statement because from above we've noted that they both are the same as, or they both equal 3. The multiplicative side to that is identical. If you take some number, say 2 times 4, that is 8. If we flip that around and say 4 times 2, you still get the number 8. So that's all that's saying. If you take some number times some number, you're always going to get the same even if you do that multiplication in reverse. This is a true statement because of the above work. That is the commutative property of addition and multiplication. The next property is the associative property. Again, there's an additive and there is a multiplicative property. We'll start with the additive. All it is saying for the associative property is if you take a set of numbers, it doesn't have to be 3, it doesn't have to be 4, it could be any set. All it's saying is that if you take, and it's all addition, let's say 3 plus 4. And we'll just do the same on the other side. What this property states is that if you were to do the addition of the 3 and the 4 first, and get an answer, you'd get 7 plus 2. Going further, you'd get that to be equal to 9. They are saying that result is the same as if you took 2 plus 3 first. If you took 2 plus 3, you'd get 5, and then that gives you 4, and that results in 9. Notice you get the same answer. So as long as you are adding, and it's all adding, what this property says you can do is add in any order that you'd like. You could take the back numbers and add them first. You could take the middle numbers and add them first. Or you could take the first numbers and add them first. It doesn't matter. All it's saying is that it has to be addition. So if you had something like 2 minus 3 plus 4, be very, very careful because this would not work the same. You'd have to make sure you convert it all to addition. So if you did want to do this type of problem, make sure you change it to addition first, and then you can do whatever you want from there. You can take a negative 3 plus 4, but it has to be all addition. That's the additive associative property. Very similarly, the multiplicative associative property is saying the exact same thing. If I take, let's say 2 times 3 times 4 and said 2 times 3 times 4, it's saying the exact same thing. If you wanted to multiply the back numbers first, you can. That would give you 12 times 2 in the front still, resulting in 24. And for the other side of the equal sign, let's say we took the 2 times the 3 first. Let's see if we get the same answer. 6 times 4, which we know is 24. So the associative property holds true. So all it's saying is if you take some numbers, some grouping of numbers, and you wanted to multiply them, you can multiply in any order that you want as long as it's all multiplication. If there happens to be some division in there, make sure that you change it to multiplication first. For example, if you had something like 3 divided by 2 times 4, make sure you change that to, say, 3 times 1/2 times 4. Then you can do whatever order you'd like, because 3/2 is the same as taking 3 times 1/2. The next property is the distributive property. The distributive property states that if you have some form of multiplication outside of a sum or difference of numbers, what you need to do is distribute, in air quotes, that front multiplication through to both of the numbers or all of the numbers inside of your parentheses. So for example, if I had 3 on the outside times, if there's no symbol between parentheses, that means it's multiplication. So 3 times, let's say 2 plus 4, we'll say. What the distributive property tells us to do is to take the number 3 and do this operation to both the numbers inside the parentheses. So it would be 3 times 2 and 3 times 4. 3 times 2 gives you 6, and 3 times 4 gives you a positive 12. And it is addition because, well, you have 3 times 4 gives you a positive 4, so 6 plus 12. That can be tricky, and we'll talk more about what symbol or what sign goes between these numbers as we move forward with the distributive property. This result gives you 18. And let's just check to make sure this is true. Let's go to the side and do this work using the order of operations. The order of operations tells us to do the parentheses first. So let's see what happens if you use the order of operations. This would give you 6, and we know that 3 times 6 is 18. So it does give you the same answer. It just uses a different method to get there, the distributive property. Notice this one is just its own property. There's no additive and there's no multiplicative, just the distributive property. The next one is the identity property. The identity property basically states, basically the idea behind the identity property is how can you keep a number the same. So again, there's 2 different types. There's the additive and there's the multiplicative. So let's say you had some number 4. And using the additive property, how can I keep that number being a 4 with addition? Well, that's all the property states. If you take any number adding and add a 0 to it, you will keep its identity the same. With multiplication, if you took some number times something, how can you retain its identity? How can you keep it the same number? Through multiplication, you need to multiply it by the number 1. That gives you 4 again, retaining its identity. So that is all the identity property is. How can you keep a number the same through the means of addition or multiplication? The inverse property, the idea behind the inverse property is how can we get rid of a number through multiplication and addition. So how can I take a number like 3 and make it disappear? How can I get that number to 0 using addition? Well, I basically need to just take that number 3 and add its opposite. Well, the opposite of 3 is a negative 3. When you add something's opposite, it gets you to 0. We will talk more about why we want to get numbers to 0 through the addition property and why we want to get numbers to 1 through the multiplicative property in the future. If you look at the multiplicative side, if you took the number 3, how can you get the number 3 to give you the number 1 through multiplication? Well, we all know the idea that if you take any number divided by itself, that is 1. So if you took the number 3 in this problem, how can you get that to equal 1? Well, we need to divide it by itself. Well, how do you divide by itself? You need to multiply it by the fraction of itself. So in other words, the reciprocal of the front number is all you need to multiply by to get it to equal 1. And that's all the multiplicative inverse property is telling us. And last but not least, the zero property. The idea behind the zero property is just basically a blanket statement. If you take any number and you multiply it by 0, you will always get the number 0. That is all the zero property is. Any number times 0 is 0. So now we're just going to do a couple of examples. Write the property that explains the following situation. This one is clearly the commutative property. When you're doing the writing of this, I would like you to make sure you explain the different type. If it's the additive, make sure you tell me it's the additive. If it's the multiplicative, tell me it's the multiplicative. So for this example, clearly it's the additive property because of the addition sign. This is the commutative property. Of addition. And if you want to just put a little plus in parentheses, that is fine by me. You can also simplify this by saying commutative prop addition. That would be a simpler way of doing it if you'd like. I need you to be careful on examples with parentheses. I know it is very common, or it's very easy for people to think, oh, there's parentheses, this must be the associative property. Or, oh, there's parentheses, this must be the distributive property. So I need you to be careful and distinguish between the two. What is happening in the problem, and then figure out which property it is from there. In example 2 here, if you notice, there is a sum inside the parentheses, and there's multiplication in front of that sum. If you see multiplication and sums within the same expression, that's going to be the distributive property. And we can shorthand that by saying dist property, and there is no additive or multiplicative with the distributive property, just the distributive property. And last example for this page, some number times 1 gives you that number back. So what happened to that 8? Well, nothing happened to it. It retained itself. Well, that is the identity property. So you can do identity. How did it retain its identity? Through multiplication. Equivalent expressions have the same value no matter which numbers are substituted for the variables. For example, if I just did a quick one here, if I said 2 times 3 and 4 plus 2, are these equivalent expressions? The answer is yes, because this one gives you 6 and this one gives you 6. So in other words, they are the same value, but they have different numbers on either side. So these are equivalent expressions. There's another example. 6x and 2 times 3x gives you the same value. That is all for equivalent expressions. Here are a couple examples. Using the properties, determine if they are equivalent expressions. Well, this one's going to be using the distributive property. If you take that 5 and multiply it into the parentheses, you will get the first one giving you 5y, and the second one giving you, now notice we're going to be multiplying a negative 11, so 5 times a negative 11 is a negative 55. And if you note, these are the exact same expressions, so yes, by the distributive property. Are these the equivalent expressions? Notice we have multiplication. 7 times 6 is 42 times x, and 13x. These are not the same value. The way I got 42x was by using the associative property to multiply in any order that I'd like, and then look to see, are they equal? The answer is no. So these are not equivalent expressions. Last but not least, we have a word problem. During the last 3 weeks, Jay worked 26 hours, 17 hours, and 24 hours. Use the properties and mental math to answer the question. How many hours did Jay work in all? So, how many hours did Jay work in all? That is a addition or a total question. So we're going to be taking 17, other way around, we're going to be taking 26 as it comes first. 26 hours plus 17 hours plus 24 hours. It says use the properties and mental math, so without reaching for your calculator, you should be able to do this problem. Why we're introducing this is because, if you note, we have all addition. So that means we can add in any order that we want. So we're going to take this 24 and this 26 and add that together first. The reason is because the 4 and the 6 will give us a factor of 10. Not a factor, but a 0 at the as the singles or as the ones digit. So adding these together, we get 50 plus 17, giving us 67. A very simple trick, and it works just fine for us. That is the lesson on properties of numbers. If you did not write those properties down from before, please go and do that. Otherwise, that is it, and good luck.